name is Sean Ackels, and I'm a PhD candidate here at UTSA. My research focuses on distributed controls and swarm robotics. The subject of today's presentation is the platooning of autonomous vehicles. Platooning is the cooperative control of multiple autonomous vehicles on a highway to maintain the distancing and speed between the vehicles. The purpose of platooning is to increase the safety and the efficiency of vehicles on the highway. An example of platooning can be seen in the image on the slide. In this image, multiple red cars are passing information between each other to maintain the spacing and the velocity between them. Other cars, such as the green and blue car in the upper lane, are not members of the platoon and do not pass information to the other cars. The size of the platoon changes as vehicles enter and exit the highway. Finally, infrastructure can pass further information to the platoon to increase the safety of the system. There are three different problems that are encountered when implementing platooning: clustering, consensus control, and communication. Clustering is the grouping of objects based off similar characteristics, in this case, the grouping of vehicles into platoons. Clustering must be done in real time as the number of vehicles on the highway changes. The second is consensus control, which deals with autonomously controlling multiple independent systems so they provide the same solution to a problem. Consensus control is difficult in platooning because the number of vehicles in the platoon is constantly changing and because the controller can never allow a collision between vehicles. Finally is communication, which handles passing messages between each vehicle. In platooning, there's an IEEE standardized protocol called the Vehicle Ad Hoc Network that handles messaging. Communication is very difficult because there is a limited bandwidth between the vehicles. My research will focus on improving each of these problems. The first is clustering. Clustering is a very common problem in research, and I hope that by taking state-of-the-art clustering methods from other fields and applying them to platooning, I can increase the efficiency of the system. Second is to implement a fully distributed, lightweight consensus controller that is capable of calculating new solutions to the problem in real time as the platoon changes. Finally is communication, where the majority of my work lies. Current research in platooning focuses on event-triggered scheduling mechanisms, which send messages between vehicles only when a criteria is met. This decreases the amount of bandwidth used at the cost of sending less information between vehicles, which is detrimental to the consensus control. My research will focus on dynamically adjusting the criteria so that when needed, more messages can be sent and the consensus control can be more accurate. Research in autonomous vehicles and robotics more generally is very important as more fields begin to implement autonomous systems. I hope that my research can further increase the safety of autonomous vehicles on the highway. This is the end of my presentation. Thank you for listening.